Welcome back to Quay Does Leetcode. Today I'm going to be doing problem 150, evaluate reverse Polish notation. So for this problem, you are given an array, and the array has numbers and operators in it. The operators are plus, minus, to multiply, and divide. So there are either operators or numbers, and the array is written in reverse Polish notation, which is a notation for an arithmetic expression, where I'll show you how that works. So basically, for reverse Polish notation, you're given two numbers, and then you're given an expression, a operand, and so the operand is supposed to be applied to the previous two numbers. So this would be 2 plus 1, and then you'll be given another number, and what you'd want to do is have that number, and then you're given another operand, which is multiply, and then you would take, so this 2 plus 1, so the 2 and the 1 got replaced with 2 plus 1, which is 3, and so now you have 3, 3, and what you would do is you would multiply the previous two numbers with one another, so 3 times 3, and that equals 9, and that is the answer. So that's how reverse Polish notation works. It always takes the previous two numbers and does an operation by them. And if there was, you always do an operation and replace the previous two numbers with an operation. So in the example that we were looking at, with this plus, this 2 plus 1, that would be replaced with 3. And then that's the number that you use, this 3, that's the number that you use to multiply the next 3 by. So how can you solve this? Well, you notice that you're always looking backwards. You're always looking backwards. And you're looking backwards by two things, by the previous two things. So what data structure can you use to keep track of the previous two things? Well, for that, you can use a stack. So what you can do is you can have a stack, and your stack for this example, 2, 1 plus 3 multiply, you would take your 2 and you would put it on the stack. Then you would take your 1 and put it on the stack. Now you're at something that's not a number. So if it's not a number, what you're going to do is pop this off your stack, pop this off your stack, and you're going to add them together. Now you need to change the order of your operators, because if this was a minus sign, or you need to change the order of your numbers, because if this was a minus sign or a divide sign, then you know, 1 plus 2 and 2 plus 1 is the same thing, but 1 divided by 2 and 2 divided by 1 is not the same thing. So you want to take your first thing in the stack, you want to take your top thing in the stack and make that your second number, and you want to take the next top thing in the stack and make that your first number, and then do 2 plus 1, and that will give you 3. So now you have your 3, so you're going to put that at the top of your stack. Now you see the next thing is a 3, so you're going to put a 3 on the stack. Then you come up to a multiply symbol, and then you pop your stuff off the stack. So you pop your 3, you pop your 3, and then you do 3 times 3, and that will give you 9. So that is how you would approach that problem. Now, you can do this because it's guaranteed that the given expression is always valid, and so the expression is always going to evaluate to a result. So when you do 3 times 3 and you pop it off, you're going to put a 9 there because you're replacing what your expression was with the answer. And then at the end, you're going to return whatever is on the top of your stack. And so that's your answer. And you're always guaranteed to have something at the top of your stack because the expression always evaluates to a result. And there's no division by 0. The test cases are written so you'll never be given something that's going to cause a divide by 0 error, so you don't have to worry about that edge case. And the final thing to note for this problem is that note that division between two integers should truncate towards 0. So when we write our answer in Python, to make an integer truncate towards 0, you're going to have to do, if we're dividing two numbers, we're going to have to use the int constructor and do our division. Say we're dividing A by B, we do it like that. So that is essentially how we would do that algorithm, and this will run in O of n time, because for every number we're going to be placing it on the stack, and if it's not a number, it's going to be an operation. So we're going to be looking at every single number, so that's going to be O of n time, and we're going to also have O of n space, because we could be putting if the operation was, say the example was 2 1 1 1, and we had plus plus plus, we would have to put all these numbers on the stack. So we have O of n space. So that's the algorithm. So let's see it coded up. The first thing that we need is a stack, and we're going to be using our Python list where we're only going to be pushing and popping from the list. So we can do that in O of 1 times. So we're going to be using our list as a stack. And then we're going to loop over all of the tokens, all of the characters. So we're going to do for char for a character in tokens, we're going to perform something. So we have a few cases. So our tokens can either be add, subtract, multiply, or divide, or a number. So we're going to take care of our add, subtract, multiply, and divide. So we're going to say if char equals a addition symbol, then we're going to do something. Else if char equals a subtraction symbol, then we're going to do a different thing. And if it's a multiply, we're going to do something. And if it is division, we're going to do something else. So, and finally, if it's not add, subtract, multiply, or divide, then according to the problem statement, it's going to be a number. So if it's a number, we're going to simply append it to our stack. And we're going to append the actual number because we're given a string of a number. So we're going to actually change it into an integer and give it a string. So we're going to give it our character. And we're going to append the integer into the stack. Now, okay, if we come up to a plus, we're going to pop our two numbers from the stack because there's guaranteed to be two things in the stack right now. So we're going to do, we're going to get two numbers. We're going to call them A and B. So we're going to have A, we're going to have P, B, and we're going to stack dot pop, and we're going to stack dot pop. And what we need to do is we need to add those numbers. And remember, we need to add the second number is going to be the first number that we add to the first number. So we're going to do stack dot append. So we're going to add to the top of our stack. We're going to add what is B plus A, because it doesn't really matter if we do A plus B or B plus A for this case, but that's technically the right thing to do. But it will matter for our subtraction and division. So because for addition, B plus A is the same as A plus B, but we're just going to do this way because it's technically correct. So we're adding B plus A, and now for our subtraction, we're going to do the same thing. We get A and B, and we're going to do B minus A. And then for multiplication, we're going to do the same thing, except we're going to do multiplied by A. And then for division, we're going to do the same thing, except divided by A. And remember, we're going to have to round towards 0. So we're going to have to do this. And at the end of this whole thing, we're going to have what's left on the stack is going to be the result of our expression. So we're just going to return our stack at -1, and that's going to be the top of our stack. And it should only be one thing in the stack, which is our answer. And since we're guaranteed to have an answer at the end, we are able to put this without checking that there's something in there. So that is the code, and let us run it and see what happens. So we're getting the right answer, and let's submit. And it was successfully accepted. And so that is how you solve that problem. And thanks for watching. I'll see you in the next video.